function we just did. The function we just did. Now, come on, listen up. The function we just did was this. Okay? And so in words, this is what this is saying. In words, this is saying I take the parent function x squared, okay? Then I shifted horizontally to the left 3. So when I say shift horizontally to the left 3, units, what does that function look like? It'll be what here? Minus 3 squared. Okay? Then reflect about the x-axis. So what would this then look like? Right, so I take what I see here and I take the opposite. I multiply by -1. So when I multiply this by -1, I get that. Yes. I'm sorry, I wanted to move this. You're right. It was 3 units to the what? The right. Okay, thank you. All right. And then I'm going to shift vertically down four units, right? So what would this then look like? I take this. Remember, I take this and I shift vertically down 4 units. So what does it eventually look like? It's right here, right? Okay. Now, what if someone did this? So I want to see if what we're about to do is going to be the same as this one. So what if someone said this? Take x squared. Okay, so here's x squared. And I shift vertically down 4 units. What does that become? X squared minus 4. That's what it becomes. Shift vertically down. Remember, when you shift vertically up or down, the number's on the outside. Then what if I then take this and I shift horizontally? To the right, 3 units to the right. Okay, what does that become? Minus 4, correct? All right, so then what if I reflect about the x-axis? Now remember, I take this and I got to multiply by -1. Okay? So when I reflect about the x-axis, what does that become? I got to multiply everything by -1. What does this become? What does that become? Plus 4. So is this the same as that one? No. So the order in which you do things does matter. So you got to do it in the order in which this is occurring. So I take the parent function and I do what to it at this point? Shift it to the right 3 units. Then I do what to that? Reflect. And then I always do what last? Vertical shift. If you do the vertical shift first, you're going to get the different answer. You're graphing something different. Okay, so remember the order in which you do things does matter. The vertical shift needs to be done last. Now, if you did the reflecting first before the horizontal, that didn't matter. But what must be done last? Vertical shift. Vertical shift has to be done last. Okay? All right. Now, let's talk about absolute value. So remember when we talked about the quadratic function, we used 5 points, correct? So let's see what 5 points we're going to use for the parent function absolute value of x. Okay, we're still going to use the same values for x. 0, 1, -1, 2, -2. We're still going to use those same x coordinates. But the question becomes, will that be the same? Will the y values be the same as before? Yes or no? And this is your tuition right here. This is about 10 years old. I don't even think they make Elmos anymore. Okay. So when x is 0, what's the absolute value of 0? When x is 1, what's the absolute value of 1? When x is negative 1, what's the absolute value of negative 1? When x is 2, what's the absolute value of 2? When x is negative 2, what's the absolute value of negative 2? 2. Now when I graph this, remember the shape of the absolute value function is a V. So when I graph this, now these are the 5 points you have to remember. So 0, 0, 1, 1, 2, 2, right? Negative 1, 1, negative 2, 2. So it's a V. You get 2 rays, correct? Don't make it look like a problem. It's got to be a ray, 2 rays. So that's your parent function. That's going to be the absolute value of x. So just make sure you remember those 5 points. It's easy to remember. Really, it is. X is 0, 1, negative 1, 2, negative 2. And you just find out what your y values are. Again, it helps if you do have a transparency to get you through this. So then you're going to graph the parent function. Just go ahead and trace over this. So I have this point, this point, this point, this point, and this point. Okay, and then I'm going to use transformations to graph forms of this. So let's suppose that I want to graph So let's say you want to graph g of x, which equals x plus 2, the absolute value of x plus 2 minus 3. The absolute value of x plus 2 minus 3. Now there's no reflection here. There's no reflection, right? You agree that is there a reflection or not a reflection? No. There's none. So really the order does not matter. If there's a reflection, that's when the order is going to matter. So if you want to do the vertical shift now and then the horizontal, does not matter. The orders in which I wrote matters only if you had a reflection. And also stretching or shrinking, which we're not doing anyway. All right. But here the order doesn't matter, but let's just keep the order the same. What will I do first? Horizontal shift. So remember, counterintuitive. So don't say 2 units to the right. This is 2 units to the what? Left. So think about what's happening. So I'm going to show you again what's happening with the transparency. It helps if you use these things. I'm going to go 2 units which way? To the left. 1, 2. I forgot what that constant was. 3, negative. Okay, so then I'm going to go what? Down what? 3 units. 1, 2, 3. So that's what my final graph should look like. Okay? So now don't go to Office Depot and buy a box of transparency. No, I don't. I used to have a lot before the flood. Flood took them away. So who said womp, womp, womp? All right. I don't know. That was kind of strange. All right. So what do I do? Okay. So it's going to look like this. 1, 2, and then what? Down 3. So that's how it's supposed to look. Okay. All right. So in your mind, that's what you should have as your final answer. Okay. So remember, I want to graph this. I want to graph g of x equal absolute value of x plus 2 minus 3. All right, so every point I'm going to shift which way? Horizontally to the left. How many units? 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So that's this part. So if you have to do all the transformations, then do all the transformations in one graph. It does not bother me because you don't have that miniature graph anyway. There's not a lot of transformations. How many transformations are involved here? No, two. Now, there are 3 graphs, right? But there are 2 transformations. Okay, and then the next thing you do is what? Down 3. So that's with let's use this color. So down 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And that's it. That's all you do. All right. So, and then label this one. So this is going to be g of x, which equals this. It's not that bad, guys. It's fairly easy. Oh, I know you didn't ask me that. Which one's a parent function? The absolute value of x. The one where the vertex is located where? At the origin. All right. Okay, let's do one more with absolute value. So let's do one with reflection. Now, notice, remember we talked about the stretching or shrinking? Okay, here's what you would see if this was a stretch or a shrink. You would see a number in front of the absolute value bar, like 2 times the absolute value, or 1/3. That would make it a stretch or a shrink. That would either make it look fatter or skinnier. That's what that would do. But so we're not going to do that in here. It's not something that's necessary. I would have liked to have done it, but it's going to take another 30 minutes, and I need to move on. Yes. How do I know what now? Say it again. What would you ask me? Okay, just that t-table. It's always the same points. For absolute value, it's 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, 2. Remember that t-table I did right here? Okay. So you're always going to use those points. Remember, I always said you're going to use what numbers for x? 0, 1, negative 1, 2, negative 2. You can use the same one for x. You're going to use the same x values for absolute value of x and also for what? X squared. Now, the square root, you're not going to use the same ones. But for absolute value of x and x squared, you're going to use the same x values. Now, don't go around saying I said the y values going to be the same. You know the y values are different, correct? Because when x is 2, what's 2 squared? 4, not 2. When x is negative 2, what's 2 squared? I mean negative 2 squared. 4. All right, so that's where it would change. All right.
So for this problem, the parent function is x plus 2, right?
No, it's the absolute value of x. Absolute value. Only for absolute values. We've talked about the parent function x squared. We talked about the parent function absolute value of x. How many parent, at the beginning of class, how many parent functions did I say we would go over? 3. What are they? X squared. What's the other? Absolute value of x. What's the one we're about to do? Square root of x. Those are your 3 parent functions. From those, you can build other functions. See, I build this one. I build this from which parent function? Absolute value of x. All right? Okay. Now, make sure, girl, hey. Make sure on that test too, you don't come up and say, which one's a parent function? What she said? What she said? All right, let's look at this one. All right, let's do that one. Now this time we have how many transformations? 3. The order is going to matter here because I have a reflection. So don't do the vertical shift last. I'm sorry, don't do the vertical shift first. You always do the vertical shift last. Okay, so what do you do first? All right, let me go ahead and write it here. So this one I'm trying to graph. That was x minus 4 plus 2. All right. So Jasmine, what's my parent function? No, it's not. Okay, good. All right. I think tomorrow's happy hour. All right. Okay, so what does that say I do to this parent function? Yeah, let's do the horizontal shift first. 4 units which way? To the right. 1, 2, 3, 4. Then what? Nope. Reflect. So look like this. Then what? Up 2. So that's what the final graph should look like. Okay? So when there's a reflection, you always do which transformation last? Vertical shift. All right, so on your paper, you would do the parent function and label it. So remember, this is absolute value of x. 0, 0, 1, 1, 2, 2. You're supposed to get those raised, correct? Negative 1, 1, negative 2, 2. All right, so that's my parent function. Okay, and now let's do the horizontal shift. So I'm going to take each of those points and move it which way? Okay, how many units? 4. Okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. Okay. So what I've graphed so far, if you really are interested in what this is represented, how this is represented as x minus 4, that's all I've done. So remember what that absolute value of x minus 4 means is I take the absolute value function and I shift it which way? To the right forward. That's what I just found. Now what's the next thing I do? What do I do to this? Reflect it. So the y value 2 here becomes what y value? The y value 1 becomes, the y value 0 stays 0. That's not the origin though. The y value 1 becomes, and the y value 2 becomes negative 2. All right, so you get this. So what I've really graphed was the opposite of the absolute value of x minus 4. That's what I've graphed. Now don't make the mistake of distributing a negative 1. That's not parentheses. That's absolute value, so don't distribute the negative 1. You got to leave it out in front. If this was parentheses, you could distribute, but that's not parentheses. That's absolute value, so don't distribute the negative 1. And then finally, what do? So I have, see, I have this part here. So the only thing missing is at what? Plus 2. So I'm going to use a different color for that. So all these 5 points will move up 2 units, correct? All right, so I'm trying to use a different color. Right, so let's suppose, so this point here, I'm going to move up 2 units. Is it 2 yet? 2. This is going to move up, sorry, which one? This right here is going to move up what? 2. This will move up what? 2. This will move up 2, and this will move up 2. So this is what you get. If you have access to something like this, it does help you to make sure you got this correct. So first of all, I do what to this? Moved it to the right 4, correct? That's this. Then I do what to it? Reflected it. I get that, and then I do what to it? Shift it up 2, and I get that. Okay? All right, now make sure you label that final graph, though. So you got to tell me that this is g of x, which is what? That? And that's all you do. Okay? Any questions? It's not that bad. Okay, let's look at the square root. All right, square root function. So remember, for each parent function, we listed some points you have to use each time. So let's do the same thing for square root. Okay, so my parent function is going to look like this. Now you got to remember something about the square root of x. What kind of numbers can you take the square root of? R, positive R. I want you to say positive or 0. Positive or 0. You can't take the square root of a negative number and get a real number. What kind of number you get? Imaginary. So I can take the square root of 0. What's the square root of 0? 0. I can take the square root of 1. What's the square root of 1? The square root of 2 is 1 point something, right? So I can take the square root of any positive number or 0. So just remember that your domain here would be any number bigger than or equal to 0. Now the reason we didn't talk about domain the last one because the domain was all real numbers. So when I did that t-table, I could use any real number I wanted to for x. Y'all do see that the domain of all these are real numbers, right? Because you have arrows pointing in both directions, the same direction. So negative infinity what? Infinity for all of them. The same thing for square root. Quadratic. Here, though, you're restricted. I can't use any negative numbers. So when I do the t-table, I'm going to put on here the smallest number I can use. What's the smallest number I can use? 0. So when x is 0, what's the square root of 0? When x is 1, what's the square root of 1? And I'm going to go ahead and use a perfect square next. When x is 4, what's the square root of 4? 2. Okay? Now, those are the three numbers you're going to use. Now, you can use 9, although the grid may not be long enough. So if x is 9, what's the square root of 9? 3. But definitely use those three numbers. Now, when you graph the square root function, notice how it's going to look. And pay close attention to what I'm about to tell you. So when I graph this, I have 0, 0, right? Y'all agree? I have 1, 1. I have 4, what? 2, and I do have a 9 here, so let's use I have a 9, what? 3. So when I graph it, it's a curve that looks like this. You'll see it? You'll see it. When I rotate, I want you to notice something. When I rotate it, what does it look like? Half of a parabola. All right. In fact, the square root of x is the square root of x squared. Is the inverse of x. Is the inverse of x squared. Square root of x. So it's half a parabola. So when you draw these square root, the transformations kind of rotates to make sure it's looking like the graph is supposed to be. All right. So that's going to be your parent function. F of x equals square root of x. And from there, we're going to use transformations to graph other functions. So let me go ahead and trace over this one. So I get this, 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 and this. All right. Okay. Now, let's graph this. So number one, let's say you want to graph g of x, which equals the square root of x plus 3 minus 1. X plus 3, the square root of x plus 3 minus 1. How many transformations are there here? 2. This one that I'm pointing to is what kind of transformation? Horizontal translation. 3 units which way? To the left. And then what? Down 1. So let's look what's going to look like. So 3 units to the left and down 1, right? So watch. 3 units to the left. 1, 2, 3. See it? And then what? Down 1. So that's what it's supposed to look like. The blue would be the final graph. Okay? All right. Now, in terms of putting all this on the grid paper, it's going to be a little bit messy for this one. But let's go ahead and do this. So you're gonna first of all shift to 3 units which way? To the left. So 1, 2, 3. Here, how many units? 3 to the left, right? 1, 2, 3. 1, 2, 3. And you could do this 1, 2, 3. So I get this graph. It's like this. Okay? All right. Then what do I do next? Now remember, this is the square root of x plus 3. Okay, what do I do next to square root of x plus 3? Go down. Is it down 1? Yep. Go down 1. So all these points will go down 1. 1, down 1, down 1, down 1. See it? So down 1, down 1, down 1, down 1. So the pink graph is your final graph. So that's g of x, which equals the square root of x plus 3 minus 1. Okay? You see what you're going to put on the paper, your grid paper on the worksheets? Really, you just need the parent function and Jasmine, what's the parent function here? Square root of x. So all you really need is the square root of x and the pink graph. That's all you need. But some of you, and it's difficult if you don't actually do the other transformations. So if you need to do all this graphing, then do it. When you list a transformation, so the worksheet says to list them, correct? So when you list them, here's how you're going to say it. Make sure you write it like this. You're going to say graph the square root of x, then shift horizontally 3 units to the what? To the left, then shift vertically down 1 unit. And that's what you would say. Okay? All right, any questions on this? All right. Okay, so that's the stuff with transformations. And then if there was a negative out here, you would just do what to it? Reflect it. Okay? All right, so work on, I think there are 2 worksheets in this one? No, 3. One for each parent function. Okay? All right, now, so that's the end of that part. Okay, now we're going to kind of start talking. Now you're going to need your calculator. What we're about to do, we're going to kind of start talking about exponentials. But I noticed I didn't give you any worksheets there because we're not going to do enough to do a worksheet on it. I won't be able to do that until Tuesday. Now, don't forget your test is Tuesday. What time do you need to be here Tuesday? Well, you need to be here by 6:30, right? But if you want to start it earlier, I'm not going to be here at 5. What time? Maybe 5:45. I'm here at 5:45. You can start. So whenever I'm here is when you can start. Now, some of you, if you come at 7, what time am I picking this thing up? 8 o'clock. Because what happens from 8 to 9? Okay. All right. All Okay, so